you guys, welcome to 7.3. Our learning target today is I can classify and construct triangles. So that's the main deal that we're working on. Classifying is being able to analyze them based on what kind of angles they have and what their side lengths look like. So let's talk through these four examples here. We are going to give them names, and I'm not talking like Brittany because she's cute and Bob because, well, he's got a couple extra pounds, and, Fred because Fred's always right, and this person, man, they are very balanced, so we'll call them Theo. No, we're not going to call them names. We're going to actually give them names that reflect what kind of angles they have in there, okay? So although this is a very cute triangle, it's called acute because all the angles are less than 90 degrees, okay? They are all acute. This one is called obtuse because when we look at this angle right here, we see that it is greater than 90 degrees. So that's greater than 90. It means this whole triangle is going to be called an obtuse triangle. This one, you're going to notice two parts of the triangle, the base and the height, fall along these grid lines. So we know that it meets at a 90-degree angle, which we call a right angle. So any triangle that has a 90-degree angle is a right triangle. This final one has to be my favorite. It's equilateral, meaning all the angles are the same and all the side lengths are the same. So it's easy peasy, and we know the sum of the interior angles of a triangle adds up to 180. So we know this angle is 60 degrees, this is 60 degrees, and this is 60 degrees. Equilateral triangles are pretty awesome. Okay, the next way we're going to classify triangles is based on how many congruent sides they have. And congruent is a way to say that they have the same side length, okay? So if we look at a scalene triangle, they have 0 congruent sides. And I'm going to put a big 0 in there. 0 congruent sides, scalene. Isosceles has 2 congruent sides. When you see a mark through a side that looks the same, it means this side is equal to this side. And so we would say we have 2 congruent sides there. In an equilateral triangle, we would have 3 equal sides. So each side length is the same. So in an equilateral triangle, 3 equal sides. Isosceles, 2 equal sides. One way that you can think about that is if you said, if you think of these as sleeves, if you have a shirt, okay, wow, this is going to be a great shirt. Ooh, look at that. How many sleeves do you normally have on a shirt? You normally have 2 sleeves on a shirt. Isosceles, 2 equal sleeves. Oh, sorry, 2 equal sides. There we go. So in your homework today, you are going to have to look at lots of different triangles and identify them using as many of these terms as you possibly can. Okay, so up here, you would need to say you could say it's an acute scalene triangle. Now, if we had an isosceles triangle that perhaps had an obtuse angle here, let's imagine that we have one that looks more like that. Sides are equal. You could say you have an obtuse isosceles triangle. Okay? Now, it's also possible to have a right isosceles triangle. So you have to think about which of these classifications apply and then name the type of triangle that you have. Okay? Very important. So name what types of angles you see first. That's going to come first. And then the type of triangle you have. Does that make sense? Let's look at a couple examples and see if we can solve them together. And then I'm going to teach you about using protractors. All right, so here is a triangle we're looking at. The first thing you might notice is what kind of angle does it have? Are all the angles acute? Well, no. Is there an obtuse angle? Is there an angle greater than 90? So what we notice is that we have a 90-degree angle here. And that tells us it's a right triangle, right? But then we have to look at other parts of this. Do we have two equal sides? We do. Remember, we have two equal sleeves on a shirt, so it's going to be a right isosceles. Remember, we're going to use as many terms as we possibly can to describe this triangle. Okay, so let's take a look at this triangle. We notice that this angle is obtuse. Right off the bat, it's over 90 degrees, so it's an obtuse triangle. Now let's talk about these different angle measures down here. We don't see any marks on the sides, and we notice that these are different angle measures, so we know that they do not have the same length. So if we are dealing with this triangle that does not have any sides that are the same length, we know it's going to be called a scalene. Okay, so it's an obtuse scalene triangle. Okay, so there is a little bit of work with constructing triangles, and I want you guys to remember how to use a protractor. You can print one out online if you need to, but I want you to remember that this hole that's usually in the bottom of a protractor should be right at the vertex of your angle, and the vertex is just a fancy vocabulary word to tell you where those two rays here meet. Okay, so you put your vertex there, you make sure this line lines up exactly along your bottom line here, and then you are going to pick the scale that starts at 0 from your bottom line. And you're going to notice there's two scales here. We have 10 and we have 170. Well, we're going to start at 0, so we're going to use this inner scale. So we're going to go 0, 10, 20, 30, 40, 50, and it looks like it's about 51 right there. So this would be a 51-degree angle. Okay? Now, that's starting from this side. I want you to get a little bit of practice if we were starting from another side. So here we are starting from the other side. Remember, this hole goes on your vertex. This bottom line has to be lined up on there. And then you're going to pick the right scale that starts at 0 here. So here we're using the outside scale. And this angle is going to be exactly 100 degrees. Okay, the final thing I want you guys to know is that when you name an angle, sometimes there will be letters on here. Let's say it was A, B, C. The way to write that would be angle A, B, C. And that's just the correct way to name it. You make sure that the middle letter is your vertex, and this little symbol means angle. So we know it's an angle made by these points, A, B, C. Okay, here's the tricky part. Now you have to draw a triangle with a given description. So it has to have 15-degree angle, 75, and 90-degree angle. So here's my strategy for that. Just start with a flat line, put your hole right there, and you're going to look out and go 15 degrees. Make sure you start at 0, go up to 15, and we're going to put a dot right there. Okay, so we have a 15-degree angle. Now we're going to have to adjust the length of our lines based on what we see. Our next angle has to be 75 degrees. So we're going to have to flip our protractor and go here and line it up there, find our scale, so we start at 0 and go all the way over to 75. Now when you see it there, you're just going to put a dot right there at 75. And then you are going to line this up and connect the dots. Okay? Now, our final angle should be 90 degrees. We can confirm this quickly. Looks like about 90, yep, and that looks like about 90 degrees. Now, if you wanted to be absolutely certain, you could put a dot at 90, and you could adjust your protractor and make sure it lines up correctly, and it does. So that's how to draw a triangle and then erase the extra sides that are there. And then you would always want to label it. So this one's 15 degrees, this one is 75 degrees, and this one is 90 degrees. Now, as we look at this, we know it's going to be a right triangle. And as we look at the side lengths, we know none of the side lengths are going to be the same. So it's going to be a scalene. There we go. Good luck with this. Do some great thinking about side lengths, about the types of triangles that you have, and remember to be as specific as possible as you work on classifying and constructing these triangles. Thanks, guys.